All right, related rates. So this is basically the same thing that we just looked at, except before it was specifically about motion, while related rates can be about all sorts of different things. But the way you answer the question is exactly the same. So what I did here is everything that's in black is what the question gave us, and everything that's in purple is what you find out on your own, like from reading the question. So they give us this this equation, right? E is this is like an equation about electricity. Not that it really matters. So E is voltage, and the voltage is given by capital T, which is temperature. So at whatever temperature you plug in 100 degrees Celsius or whatever, and you find your voltage. Now they tell us that the temperature increases by 1 degree per minute, and they ask us is how fast is E. So how fast is the voltage increasing when the temperature is 100 degrees? So first of all, we know this right here, right? Okay, so if the temperature is increasing by 1 degree per minute, that is the derivative of temperature with respect to time. So sorry, it's a bit confusing. Capital T, lowercase t. Capital T is temperature, lowercase t is time. So we have that, right? We have temperature. We have the relation of temperature to time. And so we're trying to find how fast E is increasing at temperature equals 100, which is the same thing as saying what is the derivative of E with respect to time. So we have d capital T over d lower t, derivative of temperature with respect to time, and we have dE over dt, which is the derivative of voltage with respect to time. So, or sorry, that's not what we have, that's what we're trying to look for. So if we're trying to look for that, well, we can do this right here. We can take the derivative of voltage with respect to temperature times the derivative of temperature with respect to time. So, and the reason why that is, okay, so we have this equation right here. This is the original equation that they gave us. It's E with respect to temperature, right? So that's what we have. This is also what we have. If we combine the derivative of this, so the derivative of this is the derivative of capital E with respect to temperature. And if we combine that with what they give us here, then we can find d over dt, right? So I went over this in the last video, but again, I'll show you, right? So derivative E with respect to temperature times derivative of temperature with respect to time. Well, if you actually look at that, if you actually look at what happens when you multiply them together, derivative of temperature cancels out in both things, and you end up with what we're looking for, the derivative of E with respect to time. So this is exactly what you do. So again, these questions, they want you to just work out, they give you enough information. So they give you an equation of which you're going to find the derivative of, and they also give you a derivative already. And so you're going to combine those two to find what you're looking for. So in this case, it's pretty straightforward. We have the derivative of E with respect to time is equal to the derivative of E with respect to temperature times the derivative of temperature with respect to time. So first we find the derivative of E with respect to temperature. That's very straightforward, right? 2.800 T, derivative of that, just 2.800. And then 0.006 T squared, that's just power rule, so bring the 2 back. And so you get 0.012 T, right? Because 0.006 times 2, 0.012 T. And then you multiply that by the derivative of temperature with respect to time, which they gave us as just 1 degree per minute. So you multiply by 1. Of course, multiplying by 1 does nothing, so you end up with this equation right here, 2.800 plus 0.012 times temperature. And so this will give you the rate at which the voltage, or the rate at which E is increasing at any temperature. Now, they want us to find specifically at 100, so you're just going to plug in 100 for the temperature value. So 2.800 plus 0.012 times 100, and that equals to 4, and that is the answer to the question. So again, you could get something like, you could get a bunch of questions that are very similar to this, but they all work the same. Figure out what derivative they give you, because they'll give you some derivative. Figure out what derivative you can find given the equation that they gave you, and then figure out how you can combine those two in order to find what you're looking for. And that's it.